screen?
Yes.
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 Excellent. So today, thank you for all being here. I will start with GP4L, which initially stood for GÉANT P4 Lab. And now I can confidently mention that this G stands for Global P4 Lab, so Global P4 Lab. And essentially, it's an initiative that has started in 2019 when we wanted to have a platform in order that would be used to validate the RAR free router platform, routing platform, which is another parallel task we are doing in task 1. And the idea is that we would need to use this environment in order to test this routing code. It's quite novel and quite intriguing because creating a router is not something that is, I would say, trivial. But the lessons learned that it seems that it's doable actually. So the agenda for today is to present you globally what is GP4L, why we are calling this a global P4 lab, a quick real quick introduction to NMaaS, which will be elaborated more detailed by my colleagues, and some demos just to show you what we are aiming to do in this GN5.1 period. So the relation between GP4L and RAR free router is basically to have an environment to test our code in a relevant topology, which is a worldwide topology. So for those who don't know, it's a real quick digression of this presentation, but RAR is an open source routing platform used to create network operating system on commodity hardware. And the idea is to have a platform that is really easy to use, to install, that is able to run on different affordable platforms, such as $100 GPDK CPE or $5,000 P4 equipment that is able to run at 6.4 terabit per second and now 12.8. So for now, RAR is using free router as the control plane, but this is not set in stone. And if you need more information, we can discuss about that all together in a separate VC or meeting. The idea is to have one control plane that is able to control different data plane. P4, here we have a free example. We have GPDK data plane that is able to cope with multiple 10 gig and couple of 100 gig. We have Intel Barefoot Tofino that is obviously able to run at faster pace, like 12.8 terabits per second, which is the maximum right now. And you have the P4 Lang target, that is actually the virtual target that is used to validate the data plane code, the data plane P4 code. The difference between BMV2 and the Tofino is that Tofino is like running a Formula One, while BMV2 is like having a big SUV with an infinite with a trunk that has an infinite size, where you have a lot of memory, etc., etc. Obviously, with the Formula One, you can run faster. But this is not all. What you can do is to also run your own control plane. So let's imagine that you are very familiar to network programming, wants to run your own OSPF code. This is possible to hook your own control plane to this common API message that is really strictly the same, but basically you will be able to benefit from the powerful data plane that has been developed during GN4.3. So this data plane is able to run various protocols such as IPv4, IPv6, MPLS, segment routing, and all the bells and whistles you can imagine. So let's go back to GP4L. So the activity in GP4L has two parallel strands. The first is what I would say user community. It's make a use to raise awareness about this experimentation environment, where users from the GÉANT community can use. For example, we have the CERN who has used this environment in order to test their IPv6 flow label traffic steering, which is basically the idea of this demo that has been demonstrated in the past in various conferences, is the possibility to tag traffic. Each tag would correspond to a specific project, like, for example, Atlas CMS. And depending on the traffic flow, the value of the traffic of this label, the traffic will be conveyed differently inside the global P4 lab. So this is the idea. And the developer community is more related to use GP4L as an environment where you can create your own when you can create your own code, which is an environment where you can develop orchestration, automation, and all components that you would like to test before putting them in your own context, in your own environment. So the idea is that anyone from the community can cherry pick any component that has been developed and own this and report this development into their own context. So basically, if for any reason you are interested in integrating Netbox in your network, you just take all the work related to Netbox integration from GP4L and take it into your and report it into your own environment, which is basically almost a cut and paste. We are here to help. If you are interested, just feel free to liaise with us. The real idea is to have these two strengths: one for the demo, and use RAR-free router if necessary to demonstrate the capability to have a programmable network that would, I would say, behave slightly bit differently than the you would say the vendor approach. And the second strand will be to have the possibility to develop around this platform and complete this platform. So what we are doing now is that we are deploying a new hardware in this GP4L. We are deploying Tofino 2 switch, which are able to run 12.8 terabits per second. So it's a switch with 32 ports that are able to run at 400 gig, which is quite amazing. We are in discussion with Marvell and see if we could also start developing, but also buy some switches from them, because they have developed an ASIC called TerraLinks that is able to cope with 12.8 terabits per second of traffic also. Usual suspect, well-known Broadcom, which is everywhere. And last but not least, at a smaller scale, we can run also some codes in NVIDIA Bluefield GPU and FPGAs. So FPGAs, the good news is that ASNet has released a new platform that is able to translate P4 code to FPGA. So we can couple this char card with Tofino 1. And we have also recently purchased Tofino 1 switch that are equipped with Marvell Octeon TX2 DPU. This DPU is able to process 200 gig of traffic per second with a lot of SRAM and more memory at light line range. So you can, for example, complete the feature of Tofino 1 with deep inspection or full routing table in this situation. So the P4 lab, as I said, was simply did not exist actually. When we started in 2019, the idea was to have 4 nodes in order to test the code. The code we started to write in P4, and we really started with a blank page. But then we not sure how and why we had a momentum of very good feedback from the community, and we had a lot of users who wanted to deploy and join this P4 lab, this GÉANT P4 lab, and connect their switches. So basically, we used the existing RNE connectivity in order to create a GP4L as it is. And now not sure again how and why we became a worldwide test bed. And the good and if you spot it, we have a presence in Europe, US, Latin America, Asia, in Korea, and recently we have now a new node in Tokyo, which is great because also we which is great because we have a presence almost everywhere. I did not mention Africa, but I am in discussion with Ubuntu Alliance, where they started to evaluate the possibility to deploy a node in the southern part of Africa. So that being said, we are also extending the global P4 lab. As I said, it's just the topological representation of what I just discussed before. Here in GVA 0061, GVA 062, we have the switch that are able to cope with 400 gig connection. And here we have the two switches that are equipped with Marvell Octeon. And these are the existing switches connected to the P4 switch from CERN and the existing global P4 lab going outside, if you will, going outside in the United States and Latin America. So I won't spend too much time, it's just for your reference, but the idea here is to have a cluster in Geneva where the data from CERN are closed, and the possibility to create demos and experiment at 12.8 terabits per second, with the possibility to hook nodes that are able to also process traffic with a data processing unit such as Marvell Octeon. So this is the real idea. One also idea in why Geneva, why CERN, is simply because also the probability to have a 400 gig connection will be obviously in Geneva, where ESNet, for example, I think it's already the case, will lend a 400 gig connectivity all the way to CERN. So the idea is to be able to run demonstration at 400 gig capacity, which is quite impressive, I would say, for an open source platform. This is just for your reference, but we will have new nodes from partner. You have University of Pays Basque, new nodes from University of Murcia. We have Singaren, new nodes in Caltech. We have been contacted by Bridges in order to deploy GPTK nodes in Washington, New York City, Paris, Amsterdam. And the perspective is to have some, maybe one node in Africa and a new node near Chile, in order to maybe try to do some tests with the LSST project, which is the telescope that is in Rubin Observatory. So what about monitoring? Because a very good network like that, programmable, etc., needs to provide KPIs, need to provide their view. And what I won't go I won't provide much detail, but the idea is that we are using network management as a service in order to monitor all this infrastructure. And to be honest, as a user, I think we managed to spare 1 year of network management deployment, because we just have to point and click to log, having a catalog, point and click, and in few clicks away, we are able to have Grafana, Prometheus, Netbox, Uptime, Kuma, and all this stuff. So I would say that when you have nothing, and then you gain almost 1 year of development simply by using NetMaaS, it's justified, I would say, the investment. But I will provide more detail. I will let all my colleagues provide you more detail. The key takeaway here is that you have a turnkey solution. With an experiment, with a platform that is able to run a control plane, NMaaS and global P4L, you have a turnkey solution that can expose some components that you can cherry pick and make it your own in your own context. This is the whole point of the platform activities in GÉANT. This platform is not meant to provide a solution that you have to adopt and force you to adopt. The idea is really for you to cherry pick all the components that interest you and make it your own in your own context. This is the idea. So feel free to join us if there are some topics that are interesting for you. What I propose is to spend a few moments to present you what I would call a digital twin and orchestration. Orchestration will be presented by my colleagues from NMaaS, Sonja and Vojdan. So let me show you. Can you still see my screen? Yes.
Yes, we can.
So this is the global P4 lab, real-time environment. So don't worry, all the nodes are gray simply because we are doing some experiment here. But this is real-time monitoring of the global P4 lab using a Grafana panel. And all of this idea is to have all of this automated, but also applicable in your own context. And I will show you how. So imagine that it's not the global P4 lab, but it's the SURF network or the Pioneer network or another network from RENATER. Okay, so here you have this topology, but that is described in Netbox. For those who don't know, Netbox is a DSIM that is that can be used to describe all your infrastructure. So if you have nothing, it's a very good essential tools to describe your own infrastructure, your data center, your network connectivity. You have IPAM, you have a connection. So just to show you, this is the Netbox related to global P4 lab, where we have defined some sites where we are. We have a region here, Northern Africa. So this is something that I did not invent it. I just pick it in the encyclopedia in the internet. And I put some also, I imported in a batch some countries. The idea here is that we are defining all the device in the global P4 lab here. So you see we have a bunch of device, IMS001. I won't go into the details for the demo, but all of the devices are represented in this map. And from that device, what we are doing is that we are creating, we are doing an export. So let me show you how this is done. Sudo. I don't want to cheat, so I am removing everything that is related to this export. Okay. So now let's do nrx.py. So now what I will do is that I will launch an export from Netbox to a specific output using that is Container Lab. For Container Lab export is simply a definition in the YAML file that would describe a topology. Okay, so now all of this is I would say processed. We are doing the topology extract from Netbox. So all of the information in the right are defined here. So Netbox is the source of truth. And if you see what has been created is a global P4 lab topology. So if I go here, I see that I have the nodes that have been defined and some links. So the nodes and some links. Now let's deploy this lab. Let's say that we want to look at how this lab looks like, and so basically it's your network. And then with Container Lab, we are able to run it. Okay, so if you look at the page, we are able to see that a topology has been created. And essentially, this is the representation of our work. So you might say that here, the nodes, there are less nodes than it is shown in the slide. Yes, simply because we are in the testing phase, and we did not put all the information. We are doing step by step, but here you have the digital twin of your network. And when I say digital twin, is that for instance, if I'm going here, I can SSH it. And normally I should be able to run it. And I am inside my digital twin. So if I'm going here, I see that I have one Ethernet connection connected here, one to IMS1. So all of this is configurable. So the real idea here is that this is not only related to a RAR free router. We can have in the node, we can have a Juniper router, we can have a Cisco iOS router, we can have other type of router. We can mix and match all of this. And imagine, for example, that I am running a Junos router on all my lab. But tomorrow, I want to test new iOS XR CLI. I just have to replace the definition here of Amsterdam and say, okay, I want Amsterdam to be a Cisco iOS XR. I will have just to change. I will have just to change the definition of this file here. Oh, sorry. The GP file. So here you see, I will just have to change the image of this file and make it an image that is running iOS XR node. So the basic idea is that it will help you validate new configuration, new paradigm, new topology. And in the future, we will also add a virtual traffic generator, for example, with XIA virtual container that is able to pour traffic from any node. And all of this is virtual. So it's really your digital twin. And the cherry on the cake is that all of this is alive. It's not something that you will do once. It's something that is alive that will live with your real network information.
Frédéric, 5 minutes.
Yes. That's pretty much it. I have finished. So here you will see that there is the community channel and also some reference where we will be. We did some presentation in APAN. We plan to also attend some IETF hackathon, and also maybe the next supercomputing 23-24 for next year. And that's pretty much it. Thank you. Any question?
Yes, we have 5 minutes around for questions.
Hi, Frédéric. This is Tomek from PSNC.
Yes.
One question about, you mentioned that you can swap the definition of the image emulating the virtual twin.
Yes.
How you deal with interface numbering? Because on Cisco, you can have different scheme. Yeah.
Very good question. In the export, you have the possibility to have interface mapping. So you have two choices. Either you try to map your existing real network with the modules to the local mapping, but in the end you will have to have a local mapping. Not sure if it is clear.
Yes, I understand. Thank you.
And you will have to just deal with that and say that this mapping, this router at gigabit Ethernet 000/1 will have in the virtual lab, you will have the same name at Ethernet 1111, for example. But there is a specific mapping inside it. And also you have a new platform such as Arista, who are providing also interface mapping in order to support this digital twin concept.
Yes, thank you.
All of this obviously is a work in progress, and you are invited all to I would say, if you are interested, you can just join us and we can work together in order to create your digital twin. I would say that the more topology we will create, the more we will be exhaustive in terms of topology, difference, and capability. So we can mimic a small network, big network. I'm pretty sure that, for example, with HANet, we have 1,200 nodes in the IGP. I'm pretty sure we will have to split this file in different hypervisor in order to have the load. And maybe in the long run, we can divide this load in different workload. I see a hand. Ivan, please go ahead.
Nice to see you, Frédéric. I was wondering, this container lab, is that an application? Do you provide that as a product, or it's a service of GÉANT?
Okay, good question. Container Lab, let me show my screen. Container Lab is an open source project supported by Nokia. And can you see my screen?
Yes. 2 minutes, Frédéric, right?
Yeah,
we can have more questions later after all.
So Container Lab is just even for you, Container Lab is a supported project that is able to run all of these nodes.
Okay, yeah, thanks. Great.
And if you see here, it's supported by Nokia. So I think it's a serious project. And we have added support recently, RAR-free router. You see, we are here.
Yes, I see.
So the last session today is for more questions and answers. So,
yes.
So don't worry. We can come back to this. Okay, thank you, Frédéric. We can switch to the NMaaS platform. Vojdan, Łukasz.
Yeah, thank you. Can you see my screen?
Yes.
Here we are. Okay, thank you very much. So yes, let's proceed with network management as a service. I will share this presentation with Vojdan. Okay, regarding the agenda, I will start with a short introduction to the whole NMaaS concept, but I will just spend a couple of minutes on this, and we will mostly focus on an update on recent developments and some information regarding the NMaaS GÉANT service that is provided to the GÉANT community. And then we will switch to Vojdan, and Vojdan will mention a little bit more about how we have open sourced the NMaaS components, what was the major milestone for us for quite a long time. Also, he will also explain and share some details regarding the virtual laboratory use case being, let's say, a new application for the whole NMaaS platform. That is very interesting and open, let's say, the usage of potential use of NMaaS to completely different areas than the ones that were originally planned. And we'll finalize with some brief summary of our plans for near future. Yeah, so basically NMaaS is an open source, already open source framework for orchestration of on-demand deployment of applications in a cloud environment, let's say. So typically, basically, we are giving users possibility to deploy applications via web-based portal on top of cloud environment. I won't go into details, technical details. Of course, if you have any further questions, please reach out to the NMaaS team. But I have just put a few bullets here to mention the most important facts. As already mentioned by Frédéric, we are basing our infrastructure on Kubernetes, which when we started few years ago, which was it was a new, let's say, emerging technology. By now, it is of course already very mature and proven technology and widely adopted. So we are basing our cloud on top of Kubernetes. Of course, very important for NMaaS is that it is a multi-tenant architecture, meaning that using a single NMaaS installation We can support multiple users or multiple teams or institutions, and each of those receives an isolated tenant environment that we call in NMaaS we call a domain, and in which the team or the group of users is able to deploy instances of applications dedicated to their needs. Yeah, initially it was mostly focused on monitoring their local infrastructures, and yeah, since we are deploying the applications in the cloud, and typically they are used to monitor some infrastructures that are installed remotely in users' premises, let's say. We are utilizing software-based VPNs to ensure a secure connectivity between those remote sites, and also to ensure the secure access of users to the web interfaces of the applications that they have deployed through NMaaS. Of course, it was from the very beginning. It was very important for us to make the application deployment process as easy as possible from the portal user perspective. So the user is guided through the process of installing a new application, and along the way he is also provided with what we call a configuration wizard where a user is asked to provide some basic configuration input that would properly initialize this particular instance of a new application that is being deployed. Of course, we by now we already support a wide portfolio of applications. I will comment on this in a second as well. And this portfolio is growing basically each month. What is also interesting, maybe from a technical and automation point of view, that we are also using the GitOps approach for managing the application instance configuration. So we are pushing configuration files meant for given application to a Git repository, and based on the content of this repository, the appropriate configuration is passed to the application that already runs in the Kubernetes cluster. So basically, NMaaS comes in, let's say, two flavors and can be used by users in two ways. So first of all, we are talking about an NMaaS production service that is offered for the, let's say, wide GÉANT community, including the NRENs and institutions behind the NRENs, and basically any user that would be interested in using NMaaS for his purposes. So we have, as mentioned, we have one NMaaS production instance that is available under nmaas.eu domain. Of course, this instance is fully supported by a dedicated team that works within the work package 6 task 2. Yeah, and of course the underlying infrastructure is continuously maintained, and the user support is also provided on daily basis. If you are talking about the managed service, we also have another instance of NMaaS that we call a sandbox, that users can freely use to test NMaaS out, to check how NMaaS works. Let's say that there are some default domains created, meaning those default test domains, and also there are some demo applications deployed. So there is no configuration overhead, and users can log in, and after they are approved, they can already deploy some applications and test things out. yeah, of course, when using the production service prior to the actual use, we need to set up the domain for this particular team or institution and set up the proper VPNs, what I mentioned also before. And the other flavor, let's say, of NMaaS is the self-hosted one that we plan to promote even more moving forward. Up till now, we are providing a comprehensive document installation guide that allowing to install NMaaS from scratch on top of an existing Kubernetes cluster. And if a given user or institution doesn't have a cluster yet, there we also provided some tutorials that allow to easily set up, let's say, testing environment on a local machine using some basic virtual machines, a little bit pre-configured and basically ready to go. So this is also a way to have some experience, hands-on experience with NMaaS. Regarding the production instance and basically the service that is offered by the GÉANT project to its users, it's of course offered free of charge. As mentioned, we have a dedicated team that is operating the infrastructure, maintaining the underlying infrastructure, and provides user support. And of course, currently the funding is assured till the end of this phase of the GÉANT project, but we assume that it will be also part of GÉANT Phase 2 as well. Yeah, here we have some numbers, some statistics from the production instance. For example, we are currently supporting 28 applications that can be deployed by users. Recently added were Zabbix, for example, Uptime, Kuma, Netbox mentioned by Frédéric, or health checks. I also mentioned here +2 because we have integrated 2 additional applications that support the virtual laboratory use case that will be commented by Vojdan in a minute. So by now, NMaaS is used by a number of NRENs and institutions coming from different countries and by GÉANT itself. Of course, different teams use NMaaS to, let's say, to different extent, either to monitor some actual production infrastructures or just to test applications or monitor some laboratory equipment. It's worth mentioning that NMaaS is used also by some internal, let's say, other GÉANT project teams to monitor some infrastructures that or equipment that they have, including the monitoring of the GP4L testbed that was mentioned by Frédéric. Yeah, and also NMaaS is nice also to disseminate or promote maybe applications that are developed within the GÉANT community, and this way they can be shared with others and published on NMaaS and free for the installation by other users. Regarding just an update on the, let's say, our recent activities, recently we have released NMaaS 1.5.2, a minor version of the software that included some bug fixes and some improvements of the portal from the layout perspective. And currently we're working on a new major release 1.6.0 that would comprise some major features that are planned to support the virtual lab use case that will be commented by Vojdan in a second. And also, for example, we are going to introduce this access to logs of deployed applications that was already that is a feature that was already requested some time ago. Of course, we are continuously working on adding some new applications to the catalog. typically based on user requests. Yeah, we are carrying out typical maintenance of the production and development clusters. We are providing continuous user support in setting up new domains, also providing VPN access between the user networks and the cluster, or for individual users for accessing applications through the portal. And of course, regarding dissemination activities, Frédéric gave a presentation at APAN conference along with RARE. So, and in fact, we have received some interest from Asian NRENs also regarding the NMaaS concept and what it provides. Yeah, we have submitted a proposal to TechX, but we'll see how if it's going to be accepted. Okay, and now I will give the floor to Vojdan.
Thank you, Łukasz. So just let me try to share the screen. Okay, I hope you can see it. Thank you for the introduction. So now I will start talking about open sourcing of NMaaS software components, and this is something that we have been focusing on recently. So we started with the idea to try and build a wider and more open and diverse community around NMaaS. And of course, for this, we use the open sourcing of the major existing NMaaS components. The idea is to publish them under a permissive Apache 2.0 license so that anyone can look at the code and even contribute if they so wish. A point needs to be made here that even up until now, the NMaaS components were freely available, but in a binary form, not the source code itself. It was possible to self-host NMaaS, but you couldn't look at the code up until now. To facilitate and to support this open sourcing effort, we have created a new GitHub organization called NMaaS Platform, which hosts all of the public repositories. At the moment, the 4 major NMaaS components have been open sourced, and there are plans underway to support the open sourcing of all the other relevant components, primarily the application templates. These application templates are used by the NMaaS software itself for the deployment of the customer applications. Apart from open sourcing the source code, we also began extensive work on centralizing the various documentation pages that we have. Previously, we used a public space on the GÉANT's wiki on Confluence. But to support this community building effort, we decided to create a new dedicated website called docs.nmaas.eu, which will host all of the NMaaS related content, and we're gradually moving and consolidating all of the various materials in this new location. Keeping up with the spirit of open sourcing our work, this documentation page is also hosted, the source code for the web pages themselves is hosted on a public Git repository, so others can contribute as well if they wish. The focus for the near future would be also to pay more attention to application-specific guides. This would make it easier for both new and existing users to make the most out of NMaaS and to introduce various new use cases centered around the applications which we already support. And when it comes to use cases, we are very happy to announce a major new use case which we have been working on recently. So this new use case is centered around virtual laboratories. And a brief introduction is in order here. So first, this use case is centered around hands-on educational exercises. And when it comes to such hands-on educational exercises, they are very much appreciated in various concepts. So we can use them either in formal learning, meaning some university courses maybe, or informal learning, such as self-paced courses, online courses, and so on. The common thing about all of this is that organizing such hands-on educational exercises is a very tedious process, and it demands great involvement from both the educators in terms of maintaining the infrastructure, but also in terms of adding the necessary software so that it can be used by the end participants. And this got us thinking, could we perhaps reuse NMaaS in this scenario? NMaaS already offers a general purpose application catalog, so this general purpose application catalog could be reused for this purpose if we could introduce the necessary software for organizing the exercises. And in terms of the underlying requirements, well, organizing such educational exercises would of course require some multi-tenancy approach. It would require isolation between the users, and it would require some orchestration at scale, so that the same infrastructure can be used for multiple users at once. And analyzing what NMaaS already offers, well, it basically ticks all of these boxes. And we came to the conclusion that the underlying concept is the same. NMaaS already offers containerization. The applications which are deployed are running as containers in a container runtime environment. We also leverage orchestration, as mentioned previously by Łukasz. We use the Kubernetes orchestrator. And NMaaS already has built-in concepts of multi-tenancy and per-user isolation using the domains approach. So what we aim to achieve with this new use case is to introduce benefits for both concerned parties. On one hand, we want to introduce benefits for the educational staff to make the process of organizing hands-on exercises easier, so that individual instructors do not have to manage the complete infrastructure by themselves, and also to allow them to more easily manage also the users, to have granular control over what users are capable of deploying what applications. On the other hand, there are also great benefits for the participants themselves. We call them end users. These can be students or even employees within a given organization. The idea here is to reduce the complexity of application deployment. And this is something that we have even experienced by ourselves in a teaching context. In certain cases, when we introduce a more complex application which needs to be installed by the students, not all of the students possess the required hardware. And this makes things difficult. By leveraging NMaaS and the virtual app use case, basically these complex applications can be offloaded to a centralized infrastructure. And not only would the hosting of the applications be offloaded, but also their configuration would of course be made much easier. Now the users would not have to focus on configuring and installing and deploying the application, but instead they can focus on running the application. This is very important, for example, for students which are only at the beginning of their studies, and they might not have as much experience as students in some later years in terms of spinning up new applications, configuring them, working from the command line, and so on. And of course, we must not forget that this can also be used as a playground for testing new software, because we already have an extensive application catalog. Interested parties can also try and have a look around, explore other applications that they might use, or search for alternatives. We would also like to point out that we, with the application catalog, we don't want to only focus on the computer science domain. We want also to include applications from various other domains. But of course, we would need the help from you, from the community, to do so. Going back to NMaaS and how NMaaS fits this vision, a couple of features which are required are already there in NMaaS, are already implemented. There are some improvements which are mostly quality of life improvements, which are under development, and we'll briefly mention them now. So what is already there are, of course, the NMaaS domains. This is from the very beginning of NMaaS available, and this concept of domain supports the multi-tenancy, where in the case of the virtual app, each user is given their own domain, at least one domain, which they can use for deploying applications. If required, they can also join other domains. This is useful, for example, when some teamwork is required and some applications need to be shared between the users. In that case, we can create a common or shared domain for them. What is new, but has already been implemented by now, is the support for domain groups. When organizing such educational exercises, it is very important to restrict what participants can deploy what applications. And using domain groups, basically, we can assign multiple domains to a single domain group. And at the level of the domain group, we can specify which applications can be deployed by the participating domains. So let's take an example. We are organizing some exercise for, I don't know, cybersecurity, and would only want to allow these domains participating in this cybersecurity exercise to deploy 2 specific applications and not open up the complete catalog. This is possible by domain groups. But of course, something that we realized at the beginning of the implementation of this feature is that every domain is unique. A given student, which has their own domain, might take part in multiple courses simultaneously. And these multiple courses can organize various exercises in parallel. And in this case, basically, we need to control the access to the applications. And what the domain groups allow is to create a set of allowed applications where no matter in which domain groups the domain is participating in, all of the applications which are allowed in a given domain group will be made available. So basically, we do a union of all of the available applications for all of the domain groups that the user participates in. And something which is very interesting is we have also already implemented on-demand applications. The idea here is to scale down idle instances, so that, for example, they are not left running and left consuming resources. This is very important for such educational exercises where the students might spend, for example, 2 hours per day solving the exercise and then leave and do some other work. In this case, the application that they have created will be spun down, will be shut down, but all of the data will remain. And upon their next request, it will be brought up again. Features which are in the development phase are the bulk domain creation. This will make it easier for educators to create domains. Basically, they can integrate external systems, for example, export a list of users from their learning management system into NMaaS so that all of the participants of a given course are automatically created a domain. We would also like to support bulk application deployments. This is to make the existence of NMaaS transparent, if it is so wished. In this scenario, a given educator can create on-demand multiple instances for their students and only provide information how to access these instances. The end users will not have direct interaction with NMaaS. And as mentioned previously by Łukasz, we are also starting to implement a highly requested feature, the application log viewing, which will make it easier to troubleshoot problems.
Domain, it's Vojdan.
Yes, thank you. So what we have accomplished so far is that we have already started testing out these features in a real-world course at the University of St. Cyril and Methodius in Skopje. And we are doing these tests in a course related to ethical hacking. And this pilot is already underway as we speak. The students are required to deploy a vulnerable application in their own domain and try to find out as many vulnerabilities as possible. For the near future, we plan to continue working on this virtual app use case and to implement more applications. Of course, as mentioned previously, not only focused on the computer science domain. So I would hand off to Łukasz now for plans for the future.
Yeah, just to briefly summarize, but I suppose that most of those were mentioned already. Yeah, maybe apart this major undertaking that we are planning regarding migrating our production instance to a new hardware. So this is very, of course, very important from service maintenance perspective. So we are already running on some hardware provided by PSNC, but it's of course running old by now. It's some of the equipment is running for hosting the service for over 4 years now. And now we have organized a new infrastructure that, and we will gradually migrate our domains to it, but it will still take a few months, I suppose, so that we ensure that we can stably and reliably run the service for years to come. Once production instance is migrated, we also plan to upgrade the NMaaS playground instance, the sandbox instance, and so that it is easier to keep in sync with the production one. Yeah, of course, the major goal now is to finalize the development of NMaaS 1.6.0 that should comprise all the features that would be required for the second pilot of the virtual lab at UKIM that is to be organized in November in a bit larger scale, I suppose. Maybe Vojdan would add a sentence on this as well. Of course, we are now keen on enhancing the new documentation website by moving the content that we already have, but also add the new content that would be really user friendly and user oriented, that users can have one single point of all the information needed regarding NMaaS and how to work with it. And of course, since we are now officially open source, we are of course welcoming any contributions from the community, and we are of course open to any types of collaboration. Thank you.
Thank you, Łukasz. One question. We can have more later, but now only one. Okay, thank you. Okay, thank you, Vojdan. Thank you, Łukasz. I think we can move on. Let me share my screen in a moment.
I think I see a raised hand by Ivan.
Sorry. Yes, please, Ivan.
I was wondering, since this virtual lab is kind of becoming a service, I believe, right? It's not something that you provide to the Skopje University and they manage it themselves. It's kind of supported from our side.
In this case, for the pilot, yes.
Yes.
It is hosted at PSNC, but this use case is useful for the self-hosted NMaaS version of NMaaS. The idea is for other universities to bring up their own NMaaS instance locally on their own infrastructure. This is solely for the pilot to test things out.
I see, because I was wondering, in GÉANT there is another initiative also in the direction of education and training, and I was wondering if the idea is to kind of integrate both interests and to have this virtual lab also kind of the platform for the education and training in GÉANT.
Roman, would you like to tackle?
Yes, I think, Ivan, you're referring to task 4, yeah? Maria Isabel, the courses being done by the team
courses,
there.
yes.
Yeah, we had some discussion on close collaboration. Yes, this is the plan to have some collaboration. I don't know if Ivana wants to add something more. No details at the moment, but there are some plans, yeah, to prepare to use NMaaS and this pilot later for other courses.
Yes, yeah, I just wanted to say that for all of these things that are happening within Work Package 6, we are coordinating these things among the tasks. So for all the activities within Work Package 6, we always have in mind the Network Key Academy, and we are thinking of how to do, let's say, cross promotion or to use what we have in other the tasks and subtasks, and also to promote it through Network Key Academy. So at one point of time, this will definitely come to the table to see how to merge these things together.
Yeah, because this is a promotion type, again, through the E-Academy. Okay.
Both. I mean, Network Key Academy is a place where you can actually have different material, and it is, let's say, a placeholder that is visible for itself and has their own purpose, let's say. So having as many content within the Network Key Academy can be useful for all, useful for end users, because once when they log in, even if they are looking for, let's say, Ansible, when they see other content, then they might look at that other content. Useful also for those that are producing the material, because again, people that are coming to Network Key Academy can then see their material. And also, since the platform is very good and it is supported by the GÉANT organization and the GLAD team, this we have found to be very stable and very good for navigation, for providing the content of different types. So it would be a pity not to use in one subtask something that is used for some other task. So by no means we are looking at all these resources that we have available and thinking how to make best use of it. Also, as Vojdan said, this is now prepared so that it can immediately be used at the university in Macedonia. So now when we know how it works, let's say through this pilot, although Vojdan is using this as a production thing now, then we can once see if there are some changes that needs to be done around that. And once when we are sure, then we can proceed in the next steps to promote this through Network Key Academy.
Yeah. Perhaps a comparison between the two different systems, on their benefits and drawbacks would be kind of helpful, to have a decision on how to improve on one side the virtual library, to provide and support the requirements from the Network Key Academy, and then it will come naturally, this integration.
So Network Key Academy at the moment uses Moodle platform. So those of you familiar with Moodle know that this is a type where you can actually upload the content. It has some logic behind that and has its own purpose, but Moodle itself cannot provide VMs or the environment that we are currently using in NMaaS. Those are two separate things with a different purpose. So it is now up to us to see how best to combine these two things. But by no means we do plan to look at this, how to be of service for the users and for the universities.
Okay, thanks.
Okay, thank you. Yeah, let me show my screen. Let's move to the third platform, SPA, and later we can still have time for more questions for the discussion. Okay, can you see my screen? Great, thank you. So yeah, my name is Łapacz from PSNC and from Poland, and together with Sonja Filiposka from UKIM from Macedonia, we have prepared a set of slides and demo recorded about service provider architecture, the current state and the plans. So agenda shortly, I will start with the general concept of SPA. Then I will say a few words about the production service based on SPA. It's called GCS, GÉANT Connection Service. Then we will move to the inventory 3, one of the SPA components, the key component. And I will finish with some information about the efforts that we have for GP4 Lab, the orchestrations mechanisms that we are developing in Work Packet 6 Task 2. So let's start with SPA. SPA is a modular distributed platform to orchestrate and automate network services. So shortly, it's a system to manage network services composed of many components, reusable components, and the goal is to manage services in a uniform way. Yeah. So as I said, there are a lot of components there. One of them, some of them are more important, more crucial. For example, we've got orchestrator to manage workflows. Other important components are inventories, resource inventories, service inventories. We've got self-service portal, CRM, order management component, policy management component, service catalog, and much more. Yeah. So all of them, all the components expose APIs. We decided to use Open API, REST APIs from TMF. Also, we decided to use a common information model from TMF to share data between the components of the platform. Important requirements is to use support automation in the platform wherever it's possible. Semi-automation should be also possible. Yeah. So on the right side, you can see the picture of the SPA architecture within the open digital architecture from TMF. You can see that a bunch of components exposing APIs for standard communication. So we had an architecture. We implemented the platform. We set up successful demo, and then we built a production service and the GÉANT infrastructure. The service is called GCS. So it's it's for point-to-point layer 2 circuits in the GÉANT infrastructure. It's managed by the GÉANT OC team as activation components that has access to the GÉANT routers. We use OpenNSA with its NSI interface. So it's running, it's production. We are still working on it. We receive from time to time new requirements, new requests from the GÉANT OC team. So we have a UAT, user acceptance test environment to test all the new features, all the new things, and if the tests are successful, we deploy changes in the production environment. So here you can see a screenshot of the self-service portal. Also some figures on the right. So at the moment we have 44 routers in the topology that we manage and GCS, 24 active circuits at the moment, 36 STPs, service termination points. There are endpoints that are used to create circuits. More than 700 automated workflows have been executed so far, maybe more today. I haven't checked statistics today. And more than 600 terminated circuits. And this figure includes test circuits, because every day we have automated regular tests to make sure that the service is running correctly. So as I said, it's production. From time to time, we upgrade the service to improve the performance, to replace libraries with the newer versions. From time to time, we receive requests from the GÉANT OC team to update the topology, for example, to add a new router, to decommission a router. And every day we have automated tests on the right side with the gray background. You can see an example of report from such tests that is sent via email to the mailing list. Yeah, right now we are working on the improvements of the topology management. Not all operations to manage topology are available via portal. We still use a dedicated command line tool to manage topology, but soon all the operation for topology management will be available via portal. And last bullet here is that we have a close collaboration with 4Packet7 team working on this production service. Okay, GCS is a production service in GÉANT, so access to it is very limited. So, but we wanted to show how it works to all interested people. So we decided to create an application in the NMaaS platform. So we had a collaboration with the NMaaS team. We created an application in the NMaaS catalog. It's a kind of sandbox for testing layer 2 point-to-point connection service. So all SPA components have default settings. OpenNSA has test simple topology, and all service lifecycle actions are available for users. So our user can create a circuit in this simple topology, in the simple network, can deactivate, activate, and terminate. Yeah. Yeah, so no need to have our own resources, just an account in the NMaaS platform, a few clicks, and the SPA, the test instance, can be instantiated. Okay, so some time ago we realized that it's very difficult to convince service providers to use the SPA as a product, the whole platform. But we have seen the interest to use some components, SPA components, especially inventory. Right, the inventory is a key component of the platform. In fact, in the architecture, we have two separate components: service inventory to manage information about service instances, and there is also resource inventory that stores information about resources. We implemented those components as a one application, as a source of truth automation. And the application exposes REST APIs from TMF. And right now we are working on a new version. We call it inventory free, based on the experience with the old version of the application. So the new version is implemented from scratch. Still, we use Java language for that. Still use the same APIs from TMF. We replaced a relational database that we had in the inventory tool with NoSQL, MongoDB to store JSON documents. So data models can be easily updated in this case. So, we had a discussion with people from service providers that it's for them it's very flexible because data model can change, new resources may come up, and the structures, the data model should not be static. What else? We improved in this new version of the inventory the performance. REST API is secured with Keycloak. And we wanted inventory free to be as simple as possible. Yeah. So we didn't want to store in this application the whole history of changes, changes of services or resources. But of course, we have to keep this history somewhere. So we implemented a new supporting application. We call it Event Listener, which receives notifications from the inventory free when a resource or a service is added or modified or removed from the inventory. So all the history of changes in the inventory free are stored in this supporting Event Listener application. So on the right side on the slide, you can see an example of resource that can be stored in the inventory. This example was sent by Tomek Szewczyk from PSNC, who right now is testing the application. So what is great is with this kind of model is that we don't have to create a large description of a resource. There is a concept in TMF, the concept of the resource. Everything is a resource, and resource can be composed of other resources. Those resources again can be composed by other resources or have some relationships with other resources. So we can have a hierarchy of resources. We can store those resources in different inventories and just create relationship between resources. So I mentioned that Tomek and PSNC is testing this inventory free as a source of truth for a new infrastructure in Pioneer for automated configuration and monitoring. So Tomek sent me this picture, this UML, the work on the model for his resources is ongoing. Yeah, we have prepared Docker images for him for tests. Yeah, we have regular meetings about new features, improvements. Yeah, from time to time we add new things. So the work on this application is ongoing, and we are receiving feedback from tests. Yeah, and running in PSNC. Okay, last point in this presentation is orchestration for GP4L. Frédéric already mentioned about it. So right now we want to replace some manual management actions and provide orchestrated, automated solutions. So we defined some use cases and GP4L and workflows. We implemented the first use case. In a minute, I will show you a demo that was recorded by Sonja. So shortly, it's automated execution and updates of monitoring for P4 nodes and GP4 lab infrastructure. So it's an integration of Netbox inventory, Camunda orchestrator, and Uptime Kuma monitoring application. So when a user adds a new device with management address to Netbox or modified, Netbox sends a notification to the orchestrator, and then orchestrator calls Uptime Kuma. So for all the communication between components, we use REST APIs. And right now we are working on the deployment in NMaaS. Partially, we have deployment in NMaaS, for example, Netbox, but some elements are still in our development environment. But soon, complete deployment will be in NMaaS. This is the first use case. More will come, more advanced. Yeah. So now I can show you the video prepared by Sonja. Wait a moment. Okay. Okay, let's start.
Welcome to this short demo on the inventory and monitoring orchestration use case. The goal of all GP4L orchestration efforts is to implement it in a user-transparent way so that only essential actions are manually done across the tools. In this use case, we have an inventory that acts as a single source of truth and keeps essential information about the GP4L devices, and we want to automate their monitoring via their management IP address. Additional requirements include adapting to any device changes, keeping monitoring history, pausing monitoring on inventory deletes, and support for both IP version 4 and 6. Action in the inventory, which is implemented in Netbox, generates a notification which we listen to via webhooks. The orchestrator Camunda will trigger a process based on the notification and, if necessary, use REST API calls to make changes in the monitoring tool, which we implemented using Uptime Kuma. For this demo, we will be using the Netbox inventory dashboard, where we can see the list of devices and their relevant information such as status or management IP address. On the right, it's the Uptime Kuma dashboard, where we have the list of monitors and their status. Currently, we have 3 monitors for the 3 active devices that have an IP address. We will take a look at how, using orchestration, different user actions in Netbox translate to automated changes in monitoring. The first example is activating the offline device, which already has a management IP address set during its creation. The change of status that we are now going to do will trigger Camunda so that a new monitor is going to be created in Uptime Kuma with the corresponding device name. After saving the changes, you can now see on the right-hand side, a new monitor has automatically appeared and has started gathering ping data. An active device is not monitored if it has no management IP address. In this example, we are going to add a management IP address to the device. We are first going to choose the management IP address that we would like to associate with the device. And then, once the intended changes are saved, we are able to see that a new monitor has been created for the device with the corresponding management IP value. This monitor is down because the IP address is wrong and no ping responses are obtained. We are now going to try to modify the active management IP address of a device. In this case, we are going to edit the device to change the management IP address from one value to another value. And once the changes are saved, the corresponding monitor becomes associated with the new IP address value, as it can be seen in the Uptime Kuma on the right-hand side. If we take an active device offline or otherwise change its status, in the example here, we are going to change the status of the device to decommissioning and then save the values. The trigger in Camunda is going to be reflected in Uptime Kuma with a paused corresponding monitor. A paused monitor no longer actively pings, but retains its historic information. Sometimes we need to change the name of an already active device. In this example, it can be seen that the orchestration is going to ensure that the changed device name is also reflected on the monitoring dashboard. It's interesting here that the monitoring history is not lost during this change or device renaming. Our final example is deleting a management IP address of an active device. If we remove the management IP address and then save the changes, the corresponding monitor in Uptime Kuma will be paused as per the discussed requirements in the beginning. With this, we have concluded our short orchestration demo. Questions or comments, please contact us.
Okay. So, yeah, I hope that the quality was good. Yeah, that's all. So if you want to get more details about the SPA, of course we have a wiki page for that. We've got email address if you want to contact us. Yeah. Thank you very much. If you have any questions, so now we can start the short slot with questions to all the platforms presented today. So if you still have something to discuss regarding the platforms, SPA, NMaaS, or GP4L, please don't hesitate to ask.
Hi, Roman. Owen here. Can I ask a question?
Yeah, sure, please.
No, thanks very much for the presentation there. I'm just curious with Netbox and SPA and the video demonstration at the end there. Was Netbox replacing the inventory management in SPA, or was there?
Yes.
Okay.
For that use case, we replaced our SPA inventory with Netbox. To be honest, in our architecture, SPA architecture, we have defined various components, for example, inventories, right? So for us, it's not a problem to replace the implementation. Yeah. So our architecture, SPA architecture in theory is flexible. So we understand that some service providers, some institutions prefer to use Netbox. It's very popular tool. So we are not going to push, please replace it with our implementation, with our inventory. So using Netbox is fine. For example, Frédéric is satisfied. Yeah, Frédéric, you use Netbox in GP4L, and you are not going to change it because there is no reason to do it. Yeah.
Thank you very much.
Frédéric, you wanted to add something?
Let Ivan ask his question because he raised his hand before me.
Yeah, please, Ivan.
I would suggest, because I would then take away a bit the topic, and probably if Frédéric can give his.
Okay, so so basically, just to complete the answer to the idea is that the task is a platform, and basically NMaaS target different users, and you have two solutions with respect to Netbox. The first situation is that you have a user who has nothing and would like to have something. So Netbox is here to be the source of truth. That's great because it was my case, and I won a lot of time in managing GP4L simply because the team was really small. We had a lot of things to do, that in this task, and that's why that was the key strength as a user, as I saw during these past 2 years in deploying GP4L, because we were increasing a lab that has only 4 nodes to now 40 nodes, 40-ish nodes, which is incredible. And for me, for us, I would say managing 40 nodes, all the information, all this stuff, and having all of this automated using network management solutions, it was a challenge. So this is a no-brainer. The second situation is where you are already a power user. Imagine you are an NRN with already a very good DSIM and are satisfied with it. You can continue with your own DSIM using your own process, etc. However, what you can do is to have bridges that would export some or extract some information from Netbox, from your DSIM to Netbox, such as Roman did, and then from the Netbox standpoint, you have this wonder of all plugins for you, all these export these export plugins related to topology export, GNMI export if you are doing networking, infrastructure export if you are doing the basic data center. And this is where the wonder is. You can just use Netbox as a relay in order to benefit from the whole set of automation we can provide, at least in our case, because it happens we are using it also. But maybe your DSIM already has already all of it, but I'm not sure. Again, we are targeting some users, and all the community can cherry pick some components to their own and respective environment and use it. This is free for you, and we are here to help. We are working as a community, and the more people will have, the more requests we'll have, the more, I would say, topology we will have, and we can have more exhaustive situation, and that's the real idea of NMaaS actually.
So just a short comment from my side. We at the moment we use some set of tools, but for us we are flexible. For us it's fine to replace some implementation if it's needed. So as I said, for some use cases, Netbox is preferred. So we use Netbox and as the inventory. For other use cases, SPA inventory could be better. The same for orchestrator, because right now we use Camunda. It's fine. We have Java developers. They prefer Camunda because it's Java implementation. But if we have use cases to use workflow orchestrator, it's fine. It's also very good advanced tool. So yeah, we are flexible here. It depends on the use case, on the users. Yeah. Ivan, you.
Yes. Thank you, Roman. So I'm a bit confused here because what I saw here in this demonstration is a close integration between an inventory system and a monitoring system, which indeed demonstrates how you coordinate between these two different systems. But what I was missing here is the high level, because as from an orchestrator point of view, you should be defining somewhere the workflow and saying, I want this thing to happen and the other thing to happen based on some events. But the question is actually, what was in the background there? What was the thing that was saying from an inventory system, say the Netbox, I would like to have an integration or a type of monitoring appearing in the uptime Kuma, right? Please excuse me, Adam. So the question is, what was standing behind that process? What was staying there? And do you have a can you show that thing as kind of as a more as a language, or as a as a more functional display of that, so that so that I can be able tomorrow to replace the Netbox with something else, and Uptime Kuma with Zabbix or another thing, and I just have that solution with other terms.
I can answer if you want, Roman.
Yeah, please.
Okay, so first of all, Ivan, thank you for your question. It's quite relevant. What you are describing is a workflow engine. Okay, so obviously this is not the NMaaS platform objective to provide a workflow engine. And the good news is that, as Roman mentioned, for those who doesn't know what Camunda is one of example of workflow engine software that is used in this case. Okay, so what you are describing, the whole process, the workflow process, is described behind the scene using Camunda workflow engine. But this complexity is, I would say, hidden from the user, and the user, again, I'm the culprit here, because I am the one who was doing this monitoring. Each time we deploy a node, I want it to be in uptime Kuma so that I can monitor this node. So each time I'm adding a global GP4L node, a node in GP4L, sorry, it is automatically or automagically taken into account into uptime Kuma. And this is my doing. This is my workflow. This is what I defined with Roman and Sonja in this. But the good news is that we are not only tied to Camunda, which is a Java-based workflow engine. One thing, and this is one of the reasons why I will be personally at TNC, is that I want also to consider what is how to use workflow orchestrator, Surf workflow orchestrator, which is a Python-based workflow engine. And all of this workflow magic is done at this level. But again, the idea is to hide complexity behind the scene to the users. The users should just be users and not to have their brain filled with something that is, it is interesting to define a workflow. But once you have done this thousands of times, I'm pretty sure you have other things to do. And this is the real idea of NMaaS. So yeah, the workflow engine is the key, and this is what you are seeking, this high level stuff. What Sonja in her video showed is really the small step of a workflow that is called inserting a node in GP4L. First time I want it to be supervised by uptime Kuma. The next step is to have it supervised by, have the configuration management supervised by Oxidize. Then I want it to go into automatically into the Grafana panel I showed you. This is the Grafana panel. Then the Grafana panel will automatically reflect the TWAMP metric between each node. So all of this is automatic.
Yeah. Then you see all these systems that you mentioned here, they have all their peculiarities and settings and configuration hell there. So it would be really interesting if I can just focus myself on learning the Camunda or the SurfNet workflow engine, and then say this automagically have that configuration that you demonstrated here.
Yeah, very good comment, and that's the reason why maybe one day you will have in the NMaaS catalog a square that is called either Camunda or Workflow Orchestrator, so that the user will be able to define its own workflow in its own context with existing box that is inside the NMaaS catalog, whether it is Zabbix, whether this is uptime Kuma, and that's the whole point and of this task, and that and we are progressing well simply because we see a lot of momentum, a lot of interest in from all over the world. I mean, the organization from Caltech, the GNAG, we are working closely with them, and it's quite interesting to work in that environment. Ewan, sorry, please go ahead.
Yeah, no, I'm curious, Frédéric, with your in Netbox, have you created your own, for want of a better word, templates or provisioning templates? Or like if you want to build an E-line between two services, can you select? Can you do a bit of provisioning from Netbox? That's what I'm curious.
Short answer, yes, you can. You can either do this using a GNMI interface, but again, we don't want to. We need to be the approach here is to use the stock Netbox, not to add too much complexity. And if someone really needs to specific specific Netbox with specific export, and if you see that there is a critical mass related to that, we can deploy the Netbox with the specific plugin. But in that case, we need to have a Netbox community, a Netbox NREN community that will with whom we will work, I would say, every week and see, okay, now we need this plugin and make it enter into the catalog. Otherwise, it's not something realistic because, again, we have to have a trade-off between having and save the manpower in that, because each plugin needs maintenance. Each time you release a new Netbox version, you need a new plugin version because sometimes the model will change. We have experienced that already with NRX plugin. But again, as a community, and considering the whole variety of topology we have and all the equipment, I'm pretty sure we can have a decent raw database that can be shared with everyone. I'm not talking about the topology itself, but I'm talking about the model, MPV4, Junos, Cisco IO6R, R3 router. All of this can be shared. And then this is where you gain sometimes, because everyone can come and work on the raw material that are certified by your community inside the NMaaS catalog. And NMaaS is simply the default route. Then NMaaS is a platform. It's a solution, technical software, but the main whole idea is to have a default route somewhere when I say, okay, I can trust this data, and this is where cooperation is key here.
Yeah, okay. I think I know what you're doing. Within Netbox, you just define one big topology. So if you want a particular service, you just add it to that topology file rather than doing any service provisioning.
Yeah, but you can do a lot of service provisioning, but I'm pretty sure that, for example, I'm pretty sure that Surf has their own service provisioning box in their TMF diagram. I'm pretty sure that ESNet will have their own service provisioning. But if you have nothing, you can do your service provisioning from Netbox as a source of truth. It's possible. And in that case, we can also work together because it is interesting also for us. Or for anyone who needs service provisioning from Netbox, because they have nothing equivalent or actually right now.
Thanks, Frédéric. No, it's just something we're looking at the moment. I don't know how far we'll take it, but we are looking. So
sure, we are really. If this is a subject that is one of the main of your priority, we would love to work with HGANet, more people from with HGANet, and see how we can move forward. As an example, we are working with people from Belnet because they are also they have the same reflection. We have one people from Belnet in GP4L who is working with us in this topic. So why not having some people from HGANet, I don't know, GAR or DFN? I know that DFN has already their own huge monolithic robust NEMO or system, but nothing prevents other people to see what we can do with this Netbox that has it's a kind of Pandora box. You know, with it you can do a lot of things as a central point. So this is why some people are calling Netbox the source of truth. But this does not prevent you to have your own source of truth, and you just replicate data useful to trigger automation. And this automation can be the object of workflow defined by workflow orchestrator or Camunda. Not sure if I answered your question, but this is the whole idea.
No, very good. Definitely something I'll follow up with you on. So thanks for that.
Well, I just want to add that the demo presented a very simple workflow, right? It's just the beginning of work on orchestration and GP4L. For example, in the GCS service, the workflows are much more advanced, complicated. The workflows are longer. There are more calls of external systems, external applications. There are sub workflows. There are conditions. There are timers included in the workflows. So yeah, here you could see that something simple, but it's just the beginning in case of GP4L.
Yeah, this is just the beginning. And just to give you an example, I know that, for example, we have now Giovanni Cesaroni with us. Just imagine that he has developed Genie in GAR and very good network management suite, but just in case he doesn't have any DSIM yet or would like to trigger additional workflows based on Genie data, he can just hook his Genie to Netbox and then be able to benefit from workflow orchestrator or Camunda in order to deploy to do new tasks, new things that he might need to deploy for the future. I would say, for example, GNMI telemetry, but it's just an example.
Thank you, Frédéric. Any questions or comments? Okay. If not, thank you very much for your time. Thank you, Vojdan. Thank you, Łukasz and Frédéric, for very interesting presentation. Unfortunately, Sonja couldn't join us. So, Sonja, thank you. This will be recorded. Okay, and that's all. We can finish the meeting. Ivana, do you want to add something at the end?
Just to thank all the presenters and all of you for joining our Infoshare today.
Yeah, thank you. So have a nice day and see you soon. Bye-bye.
Bye.
Thank you all.
Bye-bye.
Bye-bye.
Bye.
Bye.
Bye-bye.